Let us see one problem on CDF. So the problem statement is a 3-digit message is transmitted over a noisy channel having a probability of error equal to 2 by 5 per digit. Find out corresponding CDF. So the number of digit in a message is 3. So it is a 3-digit message which is transmitted over a noisy channel. That means amongst the 3 digits, any digit can get corrupted due to noise. So that probability of that noise or probability of error or probability of corruption in that digit is equal to 2 by 5 per digit. 2 by 5 or probability of error is equal to 2 by 5. If there is a error in one digit, then that is equal to 2 by 5. That's why it is written as per digit. And you have to find the corresponding CDF. So before finding the CDF, you should be able, first step is you have to find the sample space. So the sample space could be, there are 3 digits in a message. So they have mentioned that it is related with the error in a single digit or error in the digit. It can be in single digit, 2 digits or 3 digits. So we will see how the sample space is formed. So sample space is like this, that first case could be that every digit is a correct digit. That means noise has not affected any digit in the message. Then second is, for example, one digit is corrupted. So correct, error. Likewise we have written it that first digit is correct, second is correct, third is in error. So single error can be appear in 3 different places. For example, this place, then after that this place, and after that this place. So same is written here, CEC, then ECC. After that, if there are 2 digits in error, so it can be written as CEE or EEC or ECE. Last case could be that every digit is in error, so triple E. So this is your sample space. So before starting to solve the CDF problems, you have to first form the sample space. So that we have formed. Now how to form the sample space? You have to read the problem, what they have given. Accordingly you have to form the sample space. So in this problem they have given that there is error in probability of error per digit they have given. So you have to consider how many digits can be in error. So accordingly sample space is formed. Now after that you have to assign real values to the sample space. That is the work of random variable, which assigns real values to this sample space. So x is a random variable which counts number of digits in message which are with error. Okay, so you can define x as the random variable which counts the number of digits which are not in error also. So here we are defining random variable which counts number of digits in message with error. Okay, so x, here how many digits are there with error? No digit is there with error, so x is equal to 0. Here 1 digit, so 1, then 1. Here also 1 digit in error, so 1. Then a CEE, here 2 digits are in error, so 2. Here 2, here 2, and last is 3 digits are in error. So we have defined the random variable. So you can observe here that random variable takes 0, 1, 2, 3, 4 values. So 0, then 1, 2 and 3. Now the probability of error in per digit is 2 by 5. So the probability that a single digit can get corrupted is 2 by 5. Then probability that a digit cannot be what we can say, cannot be corrupted is 1 minus PE. That is the probability that the digit is not in error. That is equal to 1 minus 2 by 5. 2 by 5, that is equal to 3 by 5. So probability that the same is written here. So x has 4 values, 0, 1, 2, 3. So you have to name that as x0, x1, x2, x3. Now this you have to use as small letters. Okay. So so first step is sample space. After that we have defined the random variable which counts number of errors, number of digits with errors. Then after that per digit probability is 2 by 5. Then per digit error probability is 2 by 5. So per digit not error probability, or that digit is in correct position, correct form, is 3 by 5. And then we have named it as x0, x1, x2, x3, 4 values, 0, 1, 2, 3. So after that you have to find the probability of the random variables, different values. So random variable x takes the values x0, then x1, x2 and x3. So what is the probability that random variable x is equal to x0? What is the probability that random variable this x takes the values, a value equal to 0? So that probability is probability of this triple C. So triple C. So because all x0 means no error, so all digits are in correct form. So that is equal to PC into PC into PC. So what is probability that digit is correct? That is equal to 3 by 5. Probability that digit is correct is 3 by 5. So total is 27 by 125. After that we have to find the probability that there is one error in a received message. That is probability x is equal to x1. So it you have to see the sample space where it is one error is one digit is in error is CCE, CEC, ECC. That means 3 forms. Okay. Now you can see that probability of C is 3 by 5, probability of C is 3 by 5, probability of E is 2 by 5. So in all, for every this portion you will get 3 by 5 into 3 by 5 into 2 by 5. So we have taken it as 3 multiplied by 3 by 5 into 3 by 5 into 2 by 5. So that is equal to 3 multiplied by 18 into 125, that is 54 by 125. Now what is the probability that there is 2 errors? So its combinations are P, C, E, E, C, ECE. So you have to take probability EE 2 times, that is equal to 2 by 5, 2 by 5. Then for C it is 3 by 5. So same for this. So instead of writing for all these 3, we have multiplied it with 3. So these values we have taken PC, PE, PE, 2 by 5, 2 by 5 into 3 by 5, and all this also has same value, this also has same value. So 3 multiplied by this one, that is equal to 36 by 125. Now what is the probability that all digits are in error? So that sample point is only 1. So probability triple E, that is equal to 2 by 5, 2 by 5, 2 by 5, that is equal to 8 by 125. So in solving the CDF problem, first we have found the sample space, then we have defined the random variable, then we have found the random variable values, and after that we have found the probability of these random variables. Now after that we have to calculate a CDF. So for calculating CDF, you have to calculate the CDF at 4 different values, that is x0, x1, x2, x3. That is x0 equal to 0, x1 1, x2 2 and x3 3. So fx x0 is equal to this is the formula, that probability x less than or equal to x0. That is fx f, this is random variable x, and this is random variables values x0, and this is the notation for CDF, capital F. And random variable is denoted as x, and its value is x0. So that its formula is probability x less than or equal to x0. This we can write it as probability x equal to x0 for this, probability x equal to x0, and plus probability x less than x0. So probability x less than x0 is 0, because there are no sample points before x0, or there are no points beyond x0 or on the negative side. So that is equal to 0. Now probability x equal to x0 we have calculated as 27 by 125. So that you have seen already, the probability x equal to x0. So we will see once again if you want. So that is equal to this one, 27 by 125. After that, so fx x naught is 27 by 125. Then fx x1 is probability x less than or equal to x1. Again this is equal to probability x equal to x1, then plus probability x equal to x naught plus probability x less than x naught. Okay, so you have to go up to less than or equal to x1. X1 is greater than x naught, so you have to go up to this one. So probability x equal to x1 value is 54 by 125 that we have found, and probability x equal to x naught is 27 by 125. So that is equal to 81 by 125. Then fx x2 is equal to probability x less than or equal to x2. That is equal to probability x equal to x2, that is 36 by 125. Then probability x equal to x1, 54 by 125, probability x equal to x naught, 27 by 125 plus probability x less than x naught, that is equal to 0. So you have to go up to x naught. So x2, then x1, x naught, and this you have to add beyond the x naught. So fx x3 is probability x less than or equal to x3, that is x3, probability x equal to x3, x2, x1, then probability x less than x naught. So that is equal to x equal to x3. X3 is 8 by 125, then 36 by 125, 54 by 125 plus 27 by 125 plus 0. So this addition is 1. Finally, at the last point of the CDF, you should get 1. And before the first point, you should get at 0. So that this is probability x less than x naught is 0. So this is 1. Now after that you have to plot the graph. So first, probability x equal to x, this is the probability of random variable values. So if it is x naught, that is 27 by 125. If it is x1, 54 by 125, x2, 36 by 125, x3, 8 by 125. Now fx CDF is at x naught, that is equal to 27 by 125. Fx is less than or equal to x naught, that is equal to 27 by 125. That means up to x naught, that is equal to 27 by 125. After probability x is less than or equal to x1, that is equal to 81 by 125. So probability x, so at x1 it is equal to 81 by 125. Then at x2, that is equal to 117 by 125. At x2, fx x2 is equal to 117 by 125. Fx x3, that is equal to 1. At x3 it is equal to 1. At x0 it is equal to fx x0, this you have to copy. Fx x0 27 by 125, x1 81 by 125, this x1, then x2, then x3, and in between that is constant to that value. So this is CDF graph.